Okay, the binomial theorem is used for expanding terms in the form a plus b raised to n. So your NC0 a raised to n, NC1 a raised to n minus 1 b. The power of, if you see in your binomial expansion, if you see, if you look at the values of c, this is your NC0, NC1, NC2, NCn.
Okay.
If you look at the power of a raised to n.
NCn becomes 1?
NCn becomes 1. The n becomes 1.
Okay.
NC0 is 1 and NCn is also 1. The Pascal's triangle, when you draw, the endpoints are 1.
Even NPN will be 1.
Yeah, NPN will be 1.
So anything n is 1.
No, NPN is not 1. NPN is n factorial.
Okay.
NPN is equal to n factorial.
Oh, it's because I have NC
n minus n factorial. So n factorial upon 0 factorial, which is n factorial.
Right, 0 factorial is 1.
Okay. 3 people and you are ringing 3 people among themselves. So 3p3 is 3 factorial.
3 factorial, right. Okay.
Don't confuse the two. I don't know why when you're doing combination, you think of combination.
So I thought they're both the same, only difference.
See, if you have
permutation,
I'll tell you. Yeah, that's there. But if you have 2 girlfriends and you're 2 timing, when you're with one girl, you think only of that girl. Don't look at the other girl.
Okay, sir.
So when you're doing combination, just look at combination. Don't think of combination.
Okay, sir.
Otherwise, you will get confused and then it will be a big problem in life. Okay?
Yeah.
You follow? Yes. Secrets. 100%. Okay. So the power of a keeps on decreasing. A raised to n, a raised to n minus 1, a raised to n minus 2,
Okay.
a raised to n minus n, which becomes 0. A raised to 0 is 1.
Okay.
The power of b keeps on increasing. B raised to 0, which we don't write as 1. B raised to 1, b raised to 2, b raised to n.
Okay, so n keeps decreasing, b keeps increasing.
Yeah, a keeps decreasing and b keeps increasing.
That's always the case?
Always the case.
It can never be that b keeps decreasing. Or is that also possible?
You can reverse the order, no? Then it doesn't matter.
So, okay.
It won't matter, your expansion will remain the same overall.
But your C always remains NC, and that always keeps increasing.
That also can be switched, it won't matter. Because the.
Oh, you have plus signs.
It won't matter, then it doesn't matter.
You have plus signs.
Besides combination, how can you find, else can find a coefficient of binomial expansion using Pascal's triangle? You've done that, no?
Yeah, 1, 1,
1,
1.
So 1,
2, 3, 2,
1, 1, 2, 1. This is the expansion of a plus b the whole square. A square plus 2ab plus b square. 1, 3, 3, 1. That is a plus b the whole cube. 1, 4, 6, 4, 1. That is a plus b raised to 4. And so on.
Okay.
Expand using binomial theorem.
Okay.
Now when you're doing this, it's very simple. What you do is, if you want to use combination, 3C0, 3C1.
We have an option to
3C2,
not choose combination.
Yeah, 3C, but it's better to use combination. 3C3.
Okay.
When there's a minus sign, you do alternate sign. Plus, minus, plus, minus.
When there's a minus sign, you do alternate.
Alternate.
Okay. So you record.
Yes. Okay. When the power of x is there, the power of x will keep on decreasing. X raised to 3, x raised to 2, x raised to 1, x raised to 0. The power of 5 will keep on decreasing. Increasing, I mean. Sorry, 5 raised to 0, 5 raised to 1, 5 raised to 2, 5 raised to 3.
Okay.
Now I'll simplify. Now, to find a 0, you can use Pascal's triangle. 1, 2, 1, 1, 3, 3, 1. So this is your 3C0, this is your 3C1, this is your 3C2, this is your 3C3.
Okay.
Correct? So now we'll expand it. So this is 1 into x cube into 1. First one I took.
Okay.
This. Now I'll take this. What will it be? Minus 3 into x square into 5. Plus. What is 3C2? 3 into x into 25.
Okay.
Correct? Minus 1 into 1 into 125.
Oh.
So then if you simplify this, this is x cube minus 15x square plus 75x minus 125 is the binomial expansion of x minus 3 relation.
Okay, so when you have a negative sign, your signs keep flipping.
Alternating.
And if it's positive, it's always
All
positive.
positive.
Okay.
That's it. End of the story. That's how you do
This is
binomial.
full binomial.
Now
But
see,
what's the biggest power they go to?
Huh?
What's the biggest non-calculator? What's the biggest power they go to?
4, 5.
4, 5.
Because there will be something like this. Find a coefficient of x raised to 4 in this.
What is that? Coefficient of x.
Like if I ask you what is the coefficient of x square?
50 minus 50.
Minus 50.
Oh, so I have to open this up and then whatever's next to x.
That's one way of doing it. That's one way of doing it.
Okay.
It's a long way of doing it. You're right. You can do that.
Oh, it's a long way of doing it.
Long way of
I
doing
thought
it.
that was a short way.
There is a short way as well.
Oh, I thought that was the short way.
No.
Well, so the second one, so how would you do it without C, without using C?
Pascal's triangle.
But so
But I want to
to
use C. Use C, then use C.
Okay.
Because you need it for each other.
Okay.
Now, in this case, you tell me one thing now. This is your first term.
Hmm.
This is your second term.
Hmm.
This is your third term.
Yeah.
So if I had to give you formula for the rth term, can you look at this and tell me the formula for the rth term?
This is a arithmetic sequence, right? Yeah, this is arithmetic.
Look at this and tell me the formula for the rth term. Suppose instead of 3 there was a r. So see, so I'll call this r as r plus 1. Suppose your, or let me put it this way, let me put the other way around. Suppose let's say NCR.
Okay.
Suppose your r is 2.
Okay.
What's your a raised to?
2 minus 2.
N minus r.
Oh, I see my, okay, I see my R is 2. Okay, N minus 1, correct.
And what is b raised to?
B to R.
And which term is this?
That's R term, N term, R term, R.
R plus 1 term.
Why
Because if this is 2, this is the third term.
Wait, I don't know.
If this is 2, this is the third term. No, I can't make it easy.
Oh, yeah, okay.
If this is 1, this is the second term.
Oh, so that's always 1 higher, okay.
The rank of the term is higher than the r that you use in the this.
That's always the case.
Always the case. No, I'm just showing it to you.
Oh.
So this is the formula to find the general term of a binomial expansion.
Is this also in the formula? No.
It is there, but it's not given so clearly. It's given in between over here.
But we need to use this, sir?
Yeah, now this is what you have to use.
So they combine sequences and binomials here.
Yeah. You have to find a coefficient of x raised to 4 in this.
Okay.
What's your n? 7.
Yeah, the power.
Power. A.
2x.
B.
3.
You want a term in x raised to 4. What's the general term formula? TR plus 1.
Equals to
NCR A raised to n minus r B raised to r. You substitute. We don't know what r is.
Okay.
Because we don't, when we expand, we don't know which term in the expansion will give me x raised to 4.
Oh.
I don't know what my r is.
Hmm.
So I'll find it out. So NCR.
You can also use Pascal triangle.
No. NCR.
Okay.
A raised to n minus r.
Okay.
B raised to r. So that is 7CR. 2 raised to 7 minus r. X raised to 7 minus r into 3r.
Okay.
What is the power of x?
7 minus r.
What do you want the power of x to be?
4.
So what should your r be?
3.
Correct? The 7 minus r is equal to 3 is equal to 4, I mean, sorry. So r should be 3. So that means this in the fourth term will give me this. If I put my r back now in this. Put the value of r back.
So if you put the value of r is 3, you will get whatever your x is.
Yeah. So 2 raised to 4, correct? X raised to 4.
3 raised to
3. What is 7C3? You know how to calculate it quickly?
7 factorial.
No, 7 into 6 into 5.
1 into 2 into 3.
3 2s are 6. Cancel it off. 16, correct? 27. X raised to 4.
Yeah.
So basically, you can use your calculator. You can do by hand also. It's 16 by 7, 56. 56. 16 into 5 is 80. 56 into 27. Do 560 into 27.
56 into 27. 1512.
15120 x raised to 4. So what is the coefficient of x raised to 4?
1510.
Now I've shown you a general method. There are obviously simpler methods for this sum, but such a simple sum will never come.
Okay. For this sum, a simpler method will just be opening it and then upright.
Correct. And then another thing you cannot see is right now. So I don't want you to confuse it. You just use one method.
You can't use Pascal's triangles in this, sir.
You expand the entire thing.
Okay, that's the same thing. But you choose NC, whatever you choose. Plus minus.
Pascal triangle same. See now this one. Same method.
As?
What I showed you, general term.
The general term.
What's your n?
5.
A.
X.
B.
2 over x.
No.
Minus 2 over x. Because the general form is a plus b.
Yeah. I want a x raised to minus 1.
Yeah.
I want a coefficient of x raised to minus 1. So I'll write this also minus 2x raised to minus 1.
Yeah.
General term formula tr plus 1
equals
ncr a raised to n minus r b raised to r. So tr plus 1 we don't know in the beginning. 5cr a raised to 5 minus r b raised to r.
Okay.
So 5cr x raised to 5 minus r minus 2 raised to r x raised to minus r. I'll combine the x's. 5cr minus 2 raised to r x raised to what?
Minus
5 minus 2r.
Yeah. And I want.
What is the power of 5 and what do we want it to be?
The power of r is the power of
X.
5 minus 2r and we want it to be minus 1.
So 5 minus 2r has to be minus 1.
So
5
3.
plus is equal to 2r. So r should be 3. Put it back here. So it will be the fourth term.
Okay, yeah.
Correct? So 5c3 into minus 2 raised to 3 into x raised to, obviously this should come minus 1. You can it's like a double check.
So that's 5 into 4 to 3 over 1 into 2 into 3.
Perfect.
Times 8. Minus 8. And x raised to minus
2 10 minus 80 over x. So what is the coefficient? Coefficient is minus 80. How many terms are there in the expansion of a plus b raised to n?
3. No, so a.
So suppose if you had a plus b the whole square, how many terms are there in the expansion?
3. No?
If you have a plus b raised to q, how many terms are there in the expansion? 4. So if you have a plus b raised to n, how many terms are there?
N plus 1.
So if you have x minus 5 raised to 3, there will be 4 terms. If you have raised to 7, how many terms would be there?
8.
So if you write to 8 terms and then choose your x raised to 4, you may do that.
But it just take much
time. So therefore the general term formula is used.
Because so they can put that power
It's like
20.
It's like the cassette player and the CD that we have. In the cassette player, if you want to listen, you're on the first song, you start a cassette, and to listen to the sixth song,
you have to listen to everything else.
Yeah, you have to rewind.
CD player, you can just
skip it. What do you mean by constant term?
The x? No.
Constant term is the term without x.
So here there is no term without x.
Suppose if I give you, write this expansion.